Session 6.4 Equations involving inverse trigonometric functions. Look at this example. We want to solve an equation for a specific variable. So we want to solve the x in this equation. Okay, so meaning that we want to isolate the x. And then x has the restriction that that will be inside the interval from 0 to pi over 2. So you could see, I sketched the graph for this equation. This is y equal to 3 cosine 2x. And x is restricted from 0 to pi over 2. So we only pay attention for the blue plot here. So what we're going to do? First, we want to get out of the 3 here. So we're going to divide it by 3 for both sides. And then y over 3 equal to cosine 2x. Now we want to isolate the 2x. We want to get out of the cosine. So definition of arc cosine, we could rewrite it to 2x equal to arc cosine y over 3. And then we still have the 2 here, so we're going to divide it by 2 for both sides. So we are done. We isolate the x in here. And then, originally the equation y equal to 3 cosine 2x, this is not the one-to-one function, right? But when we restrict the x to 0 to pi over 2, it becomes one-to-one function. And when we isolate the x, this guy has a one-to-one relationship. Example 2, solving an equation involving an inverse trigonometric functions. So we want to solve the x in here, and then we do have the arc side. Another way to write off the arc side, we could put 2 inverse of the side x equal to pi. Right? This is exactly the same thing. Okay, arc side of x or inverse side of x. And then now we're gonna divide it by 2 for both sides. Okay, so inverse side of x equal to pi over 2, we could rewrite it means sine pi over 2 equal to x. And think about it. What is sine pi over 2? Think about the unit circle. Pi over 2 is going to be here. So sine pi over 2 should be equal to 1. And we are not done yet, okay? We want to check the work. So we're going to plug it back to the original equation here, okay? We're going to check x equal to 1. So what is the arc side of 1 equal to? Arc side of 1, that will be equal to pi over 2. And then we can simplify it. So pi equal to pi. So this is good. So this is our solution set will be equal to 1. Example 3, solving an equation involving inverse trigonometric functions. Okay, this time we do have the inverse function for both sides. We do have a cosine and also the sine. So what we're gonna do, I'm looking for the x in here. And we do have the inverse side of 1/2. So let this guy equal to u. Inverse side of 1/2 equal to u. We just make up another variable. And then sine u, that will be equal to 1/2. And I'm gonna say for this u, that will be in quadrant 1. Okay, why? Do you guys still remember on the session 6.1? Look at the inverse function. When you have the inverse side of x, the quadrant of the unit circle will be 1 and 4. Okay, but why we only say this u will be in quadrant 1? Because this guy, we let it from here. And this is related to the inverse cosine of x. Inverse of the cosine of x, that will be in quadrant 1 and quadrant 2. So if you combine it together, it has to be in quadrant 1 here. Okay? Now we're gonna plug it back. We let u equal to inverse sine of 1/2. We're gonna plug it back to this guy. So we do have inverse cosine of x equal to u. And then that means cosine u equal to x. And we just think that this u has to be in quadrant 1, right? So we could use the Pythagorean theorem to find the missing part here. So here, sine u equal to 1/2. Okay, u in the quadrant 1, so opposite over hypotenuse. And then we want to find out what is my x here. So we're gonna use the x squared plus y squared equal to r squared. Plug it in, we know the r, we know the y, we are looking for the x. You should get x equal to root 3. So we're gonna plug in back to this guy, root 3 here. And then what is a cosine u? Cosine u will be adjacent over hypotenuse. So that will be root 3 over 2. Okay, example 4. Solving an inverse trigonometric equation using an identity. So we have an arc sine of x minus arc cosine of x equal to pi over 6. So we're gonna isolate one inverse function on one side of the equation. So we're gonna add arc cosine of x for both sides. You should get this guy. And this is arc sine of x. So we could rewrite it to sine of this guy equal to the x here. Okay, that's the same idea like the previous example here, right? I have an inverse cosine of x equal to u. So cosine u equal to the x. Same idea. Arc sine, that will be the same idea with the inverse sine of x. Okay, so sine of the whole thing, this guy, that will be equal to the x. And then we do have an arc cosine x here. We're gonna let arc cosine of x equal to u. So cosine u, that would be equal to x. And remember the inverse function, cosine u equal to x, that would be from quadrant 1 and quadrant 2. It means that the arc cosine of x, that will be in between 0 to pi. Now, we're gonna plug in back. What is the arc cosine of x? We just let it to the u, right? And then we're gonna apply the identity. What is a sine a plus b? That will be equal to sine a cosine b plus cosine a sine b. Okay, think about it. What is a cosine pi over 6? Use the special triangle, or you can use the unit circle. Cosine pi over 6, that will be equal to root 3 over 2. How about sine pi over 6? That's going to be equal to 1/2, right? Okay, we are not done yet. We only consider the range of arc cosine x from 0 to pi. We still have the range of the arc sine x in here. So look at this guy. This one will be the range of the arc sine in between from negative pi over 2 to pi over 2, which is going to be quadrant 4 and quadrant 1. Okay, so I would say this whole thing here, just like your u, that will be in between from negative pi over 2 to pi over 2. And then we're going to simplify. We do have the pi over 6 here. We're going to subtract pi over 6 for the whole equation. Okay, do your math. Get the same denominator here. You should get negative 2 pi over 3 here. And this one, that will be pi over 3. Okay, right? So look at here. We do have this too. We have an arc cosine x is in between 0 and pi. And we also have the arc cosine x in between negative 2 pi over 3 to pi over 3. We're going to combine it together. Okay? Because they are talking about the same thing. Arc cosine x. So when we combine together, you should get arc cosine x will be in between 0 to pi over 3. Which is going to be quadrant 1 again. Okay, we are not done yet. We are taking care of this guy. Okay, keep going. So, cosine u equal to x, that is from here. Cosine u equal to x, and we know that u will be in the quadrant 1. So we try to sketch the picture in the quadrant 1, the triangle. Okay, cosine u equal to adjacent over hypotenuse, which is going to be x over 1. And we are looking for the y here. So use the Pythagorean theorem. Plug it in. You're going to get y equal to square root of 1 minus x squared. Okay, now we're going to get back to this guy. So what is a sine u equal to? Sine will be equal to opposite over hypotenuse. Okay, which is going to be square root of 1 minus x squared. And then cosine u. Cosine u will be adjacent over hypotenuse, which is going to be x over 1. Plug it in. Since we do have 1/2 in here, I'm gonna multiply by 2 for the whole equation. Okay, times 2, you cancel out, times 2, you cancel out here. And then we're gonna subtract the x for both sides. Okay, so 2x minus x, which is gonna be equal to x. And then we're gonna take the square for the whole equation. Distribute the 3 here. And then we're gonna add 3x squared for both sides. Okay, divided by 4. And we're gonna take the square root for both sides. But keep in mind that x is in quadrant 1, it has to be positive. Okay, so x is gonna be equal to root 3 over 2. Okay, finally, we get the solution. And then we're gonna plug in back to the original equation and check the answer. Okay, x equal to root 3 over 2. We plug in here. So think about it. Sine what degree will be equal to root 3 over 2? You have to use the radian, okay, because they're given the radian. It should be pi over 3, right? And how about this one? Cosine what degree will be equal to root 3 over 2? That will be pi over 6. Get the same denominator with times 2 here, times 2 here. So you're gonna get pi over 6. So this is good. Our solution set x will be equal to root 3 over 2. Okay, for these questions, I need you guys remember that. Make sure you remember the range of the arc sine or arc cosine. Okay, that would be from session 6.1. Okay, state the quadrant 1 or quadrant 4 or the range. Without using this part, you won't be able to determine which quadrant for your u here. Okay. So we check the work. That's it.